Okay, so I will describe the Fox algorithm right now by a matrix example and a very easy example. Basically, I will give the difference between point out some differences between the normal naive approach for the matrix multiplication in the parallel system and in the Fox. What is the advantage of using the Fox algorithm? Basically, Fox algorithm is used to cut some redundancy from the normal system. So, okay, let's say I have a matrix called A equals to, just take 2 by 2 matrix just for easy to understand the stuff. And let's say I have the B matrix, which is basically, let's say 5, 7, and 6 and 8. And if we do it by hand, what we get basically, let's say the resultant matrix C equals to, so it's 1 times 5. So the rows will go column by column of the other one. So 2, 7, and then the side will be 1.6, 1 multiplication of 6, and it would be 2, 8. And finally, the for the other row, it will be 3.5 plus 4.7, and here is like 3.6, 4.8. So basically what we get is like the result is 19, 22, and here is 43 and 50. So basically, if we do this same thing using the naive approach, and we will use it in, let's say Fox, we will do it later, but what is the difference at the naive and this one? So let's say we just want to parallelize this one. So let's say we have two processors, so P naught and another one is, let's say, P1. We have two processors. So what basically does P naught computes the row 0 of C, that means the first one, and P1 calculates the row 1 of C. Okay? So to do that, what we have to do is, let's say for P naught, what we get, it's counting the row 0. So it's 1 and 2, right? So it should be 1 and 2. And then you see what if I just take 1 and 2, but for the multiplication, I need all the columns of B. So basically, I need to store all the columns of B into that process, right? So I have to copy all B in the P naught, because to multiply with this 1 and 2, I have to go through all the columns, right? So I need all the B there. And then for the P1 also, what I have to do is, let's say 3 and 4, but you see 3 and 4 goes through all the columns, right? It just follows the naive approach, what we do by hand basically. So the P1 processor also needs all the columns of B, basically all B values, right? So it also copies all the values of B. So basically we just do the same process, same stuff in two processes, but in each process, you might need only one column of A, but you need all the columns, all the values of B. So you have to copy all the values of B in each processor. So it's a bit costly, right? So here comes the Fox algorithm to just make it easier. So how does the thing works? So basically I need a bit more space for that. So let's say for the first one, P naught, basically it's 1 and 2. And for A, as it is, as like the previous one. And for B, what it does, it says, so it just sends only column 0 for the processor 0. So it's basically 5 and 7. We will do a circular shift, but later. It's the step I'm doing before the shifting. So now what I will do is like 1 and 2 and 5 and 7. If I multiply it, what we get? It's basically we're getting 19. So we got this value. And then for like P1, what it does, it just like 3 and 4, and it goes to like 6 and 8. So if I do the multiplication, what I get basically is like 50. So I got this too. Now, now here's the difference between the Fox and the other one. In the other one, for each process, you see we need all the columns of B. But here, only the columns of B which is necessary. So it saves a ton of space. Now the thing is how we can just calculate these two. So what it does is like P1 broadcast 5 and 7, sorry, P naught broadcast 5 and 7 to P1, and P1 broadcast 6 and 8 to P naught. But A stays the same. So for the P naught process, A is 1 and 2, but now the B should be 6 and 8, right? So B should be 6 and 8. We got 22 after the calculation. So we get it. And for in P1 processor, A stays the same. So it should be 3 and 4. And the thing is, what remains is, I think, 5 and 7. So after the calculation, we got 43. So we just get it. So what's the difference? You can spot like in Fox algorithm, we just only need one column of B. We don't need entire matrix. And then we just circularly shift it, and one process don't need to broadcast the whole B to all the process. Each processor needs only the column which is required. So that's why it saves a ton of space, and it's also save a lot of time. So this is why we just use Fox algorithm. That's it.